Hello everyone, we are from the School of Computer Science, Bina Nusantara University. My name is Arvin Dewonoto and I am presenting today alongside with Jeremy Wijaya and Kevin Liong. Our research title is Comparing Machine Learning Models for Global Economic Inflation Forecasting Across Multiple Countries. This work was supervised by Mrs. Diana and Mrs. Sania Priscilia. Uh, Next, we will begin with the introduction where we explain the importance of global inflation forecasting and the motivation behind this study. Next, in related work sections, we will highlight existing literature and identify the research gap that our study addresses. And we will then move to the methodology where we describe our data source, preprocessing technique, and the model we use: random forest, XGBoost, and the elastic net. Following that, we will present our results and discussions, including comparative model performance and insight from our global analysis. Finally, we will close with the conclusion, key takeaway from this research. Okay, the introduction is inflation influences everything from global policy making to business strategy. Yet, traditional models like ARIMA and FAR often fail to capture the complexity of today high-dimensional, fast-changing data. We notice that most existing studies only focus on single country cases, making global comparison extremely rare. Our research aims to bridge this gap by evaluating three machine learning models, random forest, XGBoost, and the elastic net, using a uniform framework across all 196 countries. This helps answer a critical question: which model perform best for global inflation forecasting in both accuracy and interpretability? From India to Sri Lanka to Mexico, past studies have shown that machine learning models often outperform traditional ones. But because the dataset and validation method vary so much, comparing results is like comparing apples to orange. Our study is first to use standardized pre-processing and key-fold cross-validation globally, enabling a fair apples-to-apples comparison. The results, a truly global benchmark for inflation forecasting using machine learning.
Hello, my name is Kevin Liong, and I will explain the methodology of our research. The workflow of our research can be seen on the flowchart. The first step is data retrieval. The dataset used is obtained from Kaggle, titled Global Inflation Dataset by Sazidul Islam. It consists of annual inflation data of 196 countries from the years 1980 to 2024. There are 47 columns consisting of country name, indicator name, and the rest is annual inflation. Next is pre-processing. We handled missing values by filling with the mean using simple imputer. Non-numeric columns such as indicator name are removed because they only have one unique value. We also removed country name from training because it only functions as identification. After that, the data is standardized using standard scalar and divided into training and testing set with a ratio of 80-20. Training set is for model fit and cross-validation, while testing set is for final evaluation. We then started experimenting with the three models. The random forest and XGBoost model is tuned using GridSearch CV, whereas ElasticNet is tuned using ElasticNet CV. All of them used 5-fold cross-validation. To assess model performance, we evaluated each model using R-squared, root mean squared error, and mean absolute error. If the results are not to our expectation, we repeat the experiment and evaluation step by tuning the model's hyperparameters. After that, the performance of each model is compared, and the results are visualized using scatterplot. This is the result of each model. As we can see, ElasticNet has the best performance with the highest R-squared score. that is 0.91, and it also has the lowest RMSE and MAE score. And this is the scatter plot of the actual versus predicted results of each model. For ElasticNet, the dots are the closest to the diagonal line, so it has the least spread among the other models.
Hello everyone, my name is Wijaya. So now I want to present our discussions. Why ElasticNet prevails? First, it has a collinearity control. It effectively manages the strong correlation between yearly inflation data, leading to more stable results. Second, automatic feature selection. It automatically identified and focused only on the most important historical years, reducing noise. Finally, appropriate bias. It matches the data's mostly linear structures, avoiding the risk of overfitting that more complex models face. It has policy relevant insights also. The model's simple linear structures offer full transparency, showing exactly which historical years drive the forecast. This allows decision makers to trust the result and gives them actionable guidance, unlike black box models. Ultimately, this matters because interpretable forecasts build the most trust needed to make major economic decisions. So, moving on to limitations and future work. We recognize there is two main limitations. First is that we use univariate approach. We only use historical inflation rates like the inflation rates of 1980 until 2023. No other economic indicators were included. Secondly, we only use 1 year ahead forecast only. The analysis covers only the 2024 inflation predictions. Secondly, we only use 1 year ahead forecast only. The analysis covers only the 2024 inflation predictions. Multi-step or multi-year forecasts were not examined. For the future work, first we can incorporate micro indicators. We can add auxiliary variables like GDP growth, policy rate, money supply to enable multivariate models and potentially improve accuracy. Secondly, we can extend to multi-step forecasting. Rather than using a 1 year ahead, we can generate and evaluate 2 year, 3 year, or maybe more year for inflation forecasts in future research. So in conclusions, we get the key finding is that the elastic net regression is the best model, delivering the highest accuracy and interpretability. And for the limitation, we only use univariate data and no additional macroeconomic indicators. And forecast horizon was limited to 1 year ahead. For the implications is that for this type of data, well-tuned linear model can outperform more complex one. And for the future directions, we will expand this research by adding more economic variables and extending it to longer forecast horizons. Thank you for listening to our presentation.